All right, so are we all in the right place? Linear inequalities. So we've got two sets of inequalities that we're going to do. We're going to do linear inequalities, and then we're going to bump it up on the last page to systems of linear inequalities. So the first thing we're going to do is we're going to talk about just a single linear inequality, graph it. Anytime there's an inequality symbol, you will always do some shading of some sort. Okay, so when we talk about inequalities, you have less than or equal to. You have greater than or equal to. Okay, those are your four inequalities that we are going to do. Now, we have solved linear inequalities, I believe, back in the first unit, because same thing here. If you multiply or divide both sides of an inequality by a negative number, you do flip your symbol, okay? And at some point, we may have to do that, so just keep that in mind. Now, the way you solve it, you solve them just like you would do an equation. So let's go ahead and talk about this first example. They give us this problem, and they ask us to determine which point satisfies that inequality, which makes the left side greater than or equal to the right side, okay? So in part A, they're telling us that the x value is 7, our y value is 4. I'm going to take those two numbers, plug them into their respective spots. So that would be 4 greater than or equal to negative 2 times 7, which is x, plus 9. Then I do order of operations to simplify the right side down to just one number. So that's 4 greater than or equal to negative 14 plus 9. And 4 is greater than or equal to negative 5. Is that true or false? Is 4 greater than or equal to negative 5? Okay, so that one is true. All right, so this point is a solution to this inequality because it made the left side greater than or equal to the right side. So same thing in part B. They tell you your x value is negative 1, and your y value is 3. We're going to plug it into the same problem and see if it does make the left side greater than or equal to the right side. So that would be 3 going in for y. We're going to replace x with negative 1. We're going to do the math on the right side. So that's 2 plus 9. And this statement says that 3 is greater than or equal to 11, which is false. So this point they gave us in B is not a point that works for that particular inequality. Okay, so I'm going to pause for just a moment. I'm going to give you an opportunity to plug in your 10 and your negative 5 and tell me whether that is a true or false statement, whether that point does satisfy the inequality or whether it does not. Okay, negative numbers are tricky, but if you think if 0 is here and you go to the negative side, negative 5 is closer to 0 than negative 11 is, which means negative 5 is bigger. The closer you get to 0 on the negative side, the bigger the numbers get. The further away, the smaller the numbers get on that negative side. Okay. Any questions about part C? All right. So just a basic real world example of where you could set up an inequality to solve a scenario. That doesn't mean that you could not figure this out without a formal inequality, but we're just going to set one up. So John sells t-shirts. Plain shirts cost $5. Graphic shirts cost $7. In order to match his production cost or product cost, he must make at least $1,200. Okay, so if we have $5 for each plain t-shirt, okay, I'm just using P for plain, plus $7 for each graphic t-shirt. I try to pick variables that make sense to the question, and at least $1,200. He's got to make at least $1,200 to cover the cost of making these t-shirts. Okay, at least is actually greater than or equal to, because at least means he can't make $1,000 and cover cost. He has to make at least that much or more. Do y'all agree? Okay. So first scenario says if he sells 150 plain t-shirts and 60 graphic, will that be enough to cover his $1,200 cost? Well, if I take 150 and plug it in for the number of plain t-shirts, if I take 60 and plug it in for the number of graphic t-shirts, is that going to be $1,200 or more? If it's $1,200, yes, he covers the cost. If it's not, if it's less than, he does not. So when you multiply 150 times 5, you get 750. 7 times 60 is 420. That adds up to 11,070, and that is not greater than 1,200. So no, that is not enough to cover his cost. All right, now in this next problem, we're doing a break even. So that inequality, when you break even, you want to know what makes it equal. To break even, he has to make exactly $1,200. If he makes more than that, he would have been gaining. If he made less than that, he would be losing money. We want to know exactly what it takes for him to make exactly $1,200. Now, they tell us if he sells 90 graphic t-shirts, what's the minimum number of plain shirts that he must sell to break even. So we do not know how many plain shirts. That's what we're looking for. They told us he's going to sell 90 graphics, and to break even, we want to make $1,200. That means he doesn't gain any money, he doesn't lose any money, he just earns the amount that he spent to produce these t-shirts. So when you multiply your 90 and your 7 together, that's 630. Subtract your 630 and you get 570. Divide by 5. And we get a grand total of 114. So what that means is if he sells 90 graphics and 114 plain shirts, he will break even at $1,200. Not a penny more, not a penny less, exactly $1,200. Now, could you have figured all that out without a formal inequality statement? Absolutely. But that just kind of gives you an idea of how you could put this into just a basic scenario. It's no different. How many of you have ever had to do like candy bar fundraisers for your organization or school sponsored, something, or any other kind of fundraiser? You can set up a formal inequality to figure out how much you need, how many you would need to sell. Do you have to do it that way? Absolutely not. Now, to get into the graphing of the singular linear equation or inequalities, okay, we are going to put each inequality in slope-intercept form. Just in case you forgot, that's y equals mx plus b. That's slope-intercept form. You can use your slope and your y-intercept to graph, and that's what we're going to do. The second part, when you get ready to graph, you will use a dashed line for these two symbols. You will use a solid line when you have those two symbols with the or equals to part. All right. Now, if you set this up in y equals mx plus b form, then you will shade the direction that your symbol goes. You will shade above the line for these two symbols, and you will shade below the line for the less than symbols. So above for these two, below for these two. It is very important that you isolate y, put it in that format, okay? So this problem right here is in y equals mx plus b format, okay? Two things that I know. I'm going to have a dotted line because of that symbol, and then I'm going to shade everything below the line that I draw, all right? So two things I can get from that just from looking at that y equals mx plus b equation. Now, your slope is always the number attached to x. Your beginning value or your y-intercept, remember that is always the y-intercept. I'm not going to write that down every time, but just to remind you, that's what your b value is. You begin at -1 on your graph. Since my slope is positive, that means I go up 2 and to the right 3 from this point. So start at the point you just put on there, count up 1, 2, and then go to the right 1, 2, 3 places. Now, I am going to connect these points, but I'm going to do it with a dashed line. So when you are graphing these in Math Excel, they do have a solid option and a dotted option. So make sure that you do click the dotted line option. You put a dot here, then you drag the cursor, you put your dot here, and then it will automatically fill in the dotted line for you. Now, as far as the shading goes, Math Excel has a little shading like paint bucket almost. You click the paint bucket and you click the side of the line you're supposed to shade. Well, this says less than, and if it's less than, you would shade below the line. So you would click that paint bucket, you would click the bottom side of that line, and it will automatically shade it for you. Now, if you're not really sure about graphing on Math Excel, we will get done. You will probably have about 20 minutes of class time left, maybe 30, and I can help you make sure that you are graphing these things correctly on Math Excel. All right. Now, our second equation is y is isolated. I know that this is going to be a solid line because it has the or equals to symbol. So we're going to graph a solid line this time, and we're going to shade above the line because that is a greater than or equals to sign. Now, my slope is -4, or you can write it as -4 over 1 so you can see the rise over run. What is your b value? 0. There's not a b value. We had a visible number. So technically, officially, there's a +0. But if you add anything to 0, the 0 just kind of drops out. So we're going to begin at the origin this time. I'm going to drop down 4 and run to the right 1. So from that point I just drew, I'm going to count down 4 spaces and go to the right 1. Now, solid line, because of that symbol, when you have the or equals 2 lines, it's a solid line. So I'm going to graph that. As best I can with a solid line. And then I need to shade above that line. Which side do you think would be considered above the line? The one on the left or the one on the right? The right. Okay. So when you graph it, you click your beginning point, you drag your cursor, count off your slope, click your second point, and it will fill in that line. Y'all have graphed lines on Math Excel before, right? Okay. So really the only difference is making sure that you do select the dotted line when it's needed. Okay. Now, in the next couple of examples, we have to rewrite our equations because they are not y equals, okay? So what I'm going to do in the first one, I'm going to move my 5x over. How am I going to do that? Add or subtract it? Subtract. So that's 3y less than equal to negative 5x plus 12. Now, at this point, you have to decide, keep the symbol or switch it because you are about to divide. Since we are dividing by positive 3, I'm going to keep my symbol. It doesn't matter what these numbers on the other side turn into. It matters that I'm dividing by a positive 3. So that's negative 5 over 3x, and then 12 divided by 3 turns into 4. So what I see at this point, this is going to be a solid line, and we are going to shade below that line because the direction the inequality symbol points. Your slope, negative 5 over 3. Your beginning point is positive 4. So I'm going to drop or go up to positive 4. 1, 2, 3, 4. On my y-axis, you always put that beginning point on the y-axis. I'm going to go down 5 and to the right 3. So count down 1, 2, 3, 4, 5. And to the right 1, 2, 3. That is a negatively tilted line, and our slope was negative. I am going to connect those points with a solid line. Math Excel does a better job at graphing than I do. And then we are going to shade below that line. That is the area that would get shaded. Now, put a star by number 4 because we are going to end up dividing by a negative and our symbol is going to flip. You don't always divide by negatives, but in this one we're going to. So the first thing we're going to do is we're going to move x over by subtracting it. At this point, the last step, when you divide to get y by itself, you have to decide, keep the symbol or switch it. Well, I'm dividing by a negative 6. So my symbol changes directions. Negative divide by negative, that would be a positive 1 over 6 in front of your x. If you need to put that 1 right there so you can see the 1 over 6, do that. Negative 12 divided by negative 6 is positive 2. So what I see at this point, I see a dotted line. We are going to shade above that dotted line. I have a slope that is 1 over 6 and a beginning value that is 2. So you always start with 2 on the y-axis, your b values. So go up 1, 2. From there, you go up 1 and to the right 6. So from that beginning point, we count up 1 and then over to the right 6 places. That's not a very steep line, but it is still positively tilted because our slope was positive. Make sure you connect those with a dotted line. And then you will shade everything above that line. All right. The next one I'm going to do is number 6, because number 6 doesn't have X and Y in it. Do y'all agree? It just has one variable. So if you recall, X only, when your equation only has an X, that is a vertical line. Since my only variable is isolated, I can't isolate Y. I know this is going to be a dashed line or a dotted line. We'll just keep it with dotted. And I'm going to shade everything. I can't really shade below a vertical line, but I'm going to shade everything less than that vertical line. So what I'll do is I'll find -4 on the x-axis. So I'm going to count. This is the only time I don't put my beginning point on y. So 1, 2, 3, -4. I either go directly above that or directly below it to plot a second point. So I'm just going to go up here. I mean, I could have just gone up 1, doesn't matter. This is a dotted vertical line. Kind of hard to see, but I'm trying to make them a little bit. So we're going to go straight up and down through -4. And then the side of this line that would be less than would be the left side. Because the further you move away to the left, the numbers get smaller. The further you go to the left, the numbers get smaller. Now, I am going to pause for just a minute, and I am going to let you do number 5 all on your own. Make sure you make the right choice. Do you flip your symbol? Do you not flip your symbol? Is it a dotted line versus a solid line? And shade the correct direction. Any questions about number 5? I did not flip my symbol because I divided by +12, so I didn't have to switch the direction of my symbol. With a solid line, we shade above because it's greater than or equal to. Any questions? Speak now or forever hold your peace. All right. So let's do a couple of the word problems. And then the lunch cart should be here by the time we finish. And then we will finish up the last page. All right. So Stephanie spends 10 cents per text message sent and 25 cents per picture message sent on her cell phone. Her monthly budget is $30. Write an inequality that represents this situation. So 10 cents per text plus 25 per picture, and her budget is $30. Is that greater than or equal to $30? Less than or equal to $30? Less than or equal to $30. All right. Now, we need to graph this, okay? So We need to decide which variable we want to do. Now, do you want this to be P and T or T and P? Do you want this to be T or P? P. Okay. And so basically what you just told me was X was P and Y was T. Do y'all agree? That's how we labeled it. So what I'm going to do is I'm going to put 0.10Y plus 0.25X less than or equal to 30. That way it puts it in terms of X and Y. You said P was the X-axis, so I took P out, replaced it with X. We labeled T as the Y. Okay, so now what I'm going to do is I'm going to rewrite this equation, Y equals. So that would be, and I will erase this so we can answer part B in just a second. Subtract that 0.25x. And then we're going to divide both sides by 0.10. So this is where your calculator comes in handy. We divided by a positive, so our symbol is not going to change. When I take 0.25 negative and divide it by 0.10, I get negative 2.5x. And when I take 30 and divide it by 0.10, I get 300. All right. Now, problem is I need a fraction so I can count off my slope. All right. So does anybody know how to change negative 0.25 to a fraction? All right. Well, if I put it over 1, you can't have decimals, so I'm going to move that decimal one place and make that negative 25. But if I move this decimal one place, I have to move that decimal one place, and that gives me 10. 25 over 10 reduces to 5 over 2. So I now have negative 5 over 2 as my slope. All right. So I need to start, my slope is negative 5 over 2. My y-intercept is 300. So I need to start at 300. My axis does not go up to 300. So we're going to have to modify that just a bit. Do y'all agree? Okay. So I need to break this up into some kind of increments of 10. Do we want to do increments of 25? Do we want to do increments of 50? What do you want to do? Okay. So, all right. We'll pick up there when we get back or finish lunch. And our coordinate plane into groups of 50. All right. So that means this would be 100 because that's 2, 50, 100. This would be 200. Go up 2 more. That would be 300. Okay. Now, the problem is trying to graph a slope that is negative 5 over 2. So what I'm going to do to meet that 100, so we'll go over, there's 100, 200, 300, so on and so forth. Of course, we go 400, however much we need. So what I'm going to do is I'm going to take 5 over 2. I'm going to multiply the top and the bottom by 100, and I'm going to create a slope of negative 500 over 200. I'm going to make my slope fit what we're counting. Does that make sense? Because I don't want to start at 300 and count down to 295 and then over 2 spots. Okay, so problem is we are going to have to drop below this, so it's going to be a little more challenging. So if I start at 300 and I count down 500 and then go to the right 200, that's 1, 2, 3, about there is 4, about there is 5, and then I'm going to go over 200. So that's a little bit harder to see. All right, but at least we have our line graphed. Everybody okay with that? So now we wrote an equation. We had to do a lot of tweaking. We had to take a decimal slope, turn it into a fraction. Then I had to take that fraction slope and turn it into something that would be easier for me to count off. Does that make sense? Okay. So now I can give 2 possible combinations that fit below this line, because the equation or the inequality that I just erased was a less than problem, correct? All right, so what we want to do is we want to stay above, we want to stay in this area and this area, okay? So she could make 50 phone calls and send 50 pictures and stay within her $30. That's an option, because that is below the line. Everything we pick has to be below the line. Okay. Now, so she could do 50 pictures and 50 text, and she would still stay below her $30 limit. Okay. Now, she could just send 200 text and 0 pictures and still stay below. Does that make sense? So there are lots of different combinations of how many pictures she could send and how many texts she could send, but it just said to give 2 possibilities. Okay, I could do this point, which would be 50 pictures, this point right here, and 100 text, and still stay below my $30. Okay, does that make sense? So there are unlimited combinations, but it just asked us to pick 2. All right, everybody okay with that? The next one may not be as bad. The numbers may not be as bad. So number 8, Scott makes $12 per hour babysitting and $8 working at the grocery store. He needs to make at least $600 to buy a new computer. Okay, so 12 hours babysitting plus 8 hours at the grocery store, and he has to have at least $600. If he makes more, great, but he can't make $500 because he won't have enough to buy his computer. Now here again, you need to decide which axis is the babysitting axis and which axis is the grocery axis. So I'm just going to let this be babysitting and grocery. So that means grocery is Y, babysitting is X, and I can put those in the equation and write it in terms of X and Y. So that would be 12X plus 8Y greater than or equal to 600. Solve that, so that would be 8Y greater than or equal to negative 12X plus 600 divide by a positive, nothing changes. So what I need to graph is negative 3 over 2x. Both 12 and 8 are reducible by 4. And 600 divided by 8 is 75. Now, 75 is not that big, so I'm going to count in increments of 10. Okay, so that would be 10, then 20, here's 30. We got 40, 50, 60, 70, and then of course 80, because 75 would be right here. That's our beginning point, somewhere between 70 and 80. Now, since we're counting in increments of 10, I am going to modify my slope by multiplying both numbers by 10. So my slope of negative 3 over 2, if I multiply top and bottom by 10, I can count off negative 30 over 20 easier because everything is broken up into tens. Does that make sense? So I'm going to start here at 75. When you count down 10, you are at 65, then 55, then 45. And then you count over 20. 1, 2. Again, if you do that, that's 10, 20, 30. So you stop in the middle and go over 2. And so you can see that line. So my line is going this way. Now, according to this, which side of that line is shaded? Is it the stuff in the little triangle, or is it the stuff, all this stuff out here? It's all the stuff out here. So we got a whole bunch of scenarios that we could come up with. Okay? It just says 2 possible combinations. So any point over here. Now remember, every movement you make is 10. So if I go right here, that's 60 hours of babysitting and 20 hours at the grocery store. So 60 hours babysitting, 20 hours at the grocery store. That should give him more than $600. If I came over here, that would be 80 hours of babysitting and 0 hours at the grocery store. We have an infinite set of scenarios that would provide him with $600 or more. Make sense? Okay. So sometimes you do have to tweak stuff. In the first problem, again, we had to take a decimal slope and turn it into a fraction. And then we had to change it. And then we had to do the same thing here. All right. So the last thing, y'all have any questions about that? All right. So the last thing we're going to do is we are going to do these 4 problems. We're not going to do all of them. We're not going to do the word problems because I don't think I put any of the system word problems on there in your homework. I think I just did the linear inequality questions like we just did. Okay, so a systems of inequalities, that's where you have 2 or more graphs that you have to do. So we're going to graph each one separately, and we're going to look for common shading, and I'll show you how to do that, okay? So you're going to put everything in y equals mx plus b format, just like we did. You're going to shade either solid lines or dotted lines, whichever the case may be. And then the solution is going to be where the shading of those 2 graphs overlap, okay? So in our first equation, so I'll call that equation 1, equation 2. Do y'all have that page? Okay. All right, so in equation 1, so for equation 1, my slope is -2/3. My beginning point is at -1. This is going to be a solid line, and we are going to shade below that line. Okay, so I'm going to start at -1. I'm going to count off -2, +3. This is a solid line. Sorry, my lines are crooked. They're supposed to be straight. And then technically, and I'm not going to do a whole bunch of shading. Don't go crazy with your shading. I'm just going to do a couple of marks to show that that's the side of that particular graph I need to shade. Everybody okay with that? Okay. So problem number 2. We have a slope of +1/2 and a beginning point of -8. This is also a solid line, but we will shade above that line because it's a greater than or equal to symbol. Okay, so I'm going to start at -8. So drop down 1, 2, 3, 4, 5, 6, 7. -8 should be about right there. Y'all double check and make sure I counted that correctly. I ended up on the end of the graph. Is that where y'all ended up? All right, +1. So we go up 1 and to the right 2. This is also a solid line. And I am going to shade above that line. So I'm going to keep that line and I'm going to shade everything above that line. Now, do you see the crisscross pattern? The crisscross pattern is here. Okay, it's not over here. I only see one set of shading, one set of shading. So basically, this corner of that X, when you have two lines that intersect, so I'm going to take away this part, and I'm going to take away this part. This is the area that I would click on Math Excel once I decide that is my area. Okay, don't shade anything outside of that one X. You get one corner and that's it. Everybody okay with that? All right. Now, I like this one because this is a y-only equation or inequality. Our first one, we are going to have a slope of 3/4. We are going to have a beginning point of -4 based on the inequality symbol, solid or dotted, above or below. Below. If I could spell the word below, that's not how you spell it. So I'm going to start at -4. So 1, 2, 3, -4 on the y-axis. I'm going to count up 3 and to the right 1 from that point. You said solid line. You also said shade below. So notice I just put enough lines to where I can see that the shading is below. All right, so that was for inequality number 1. Inequality number 2, y equals to a number is a horizontal line. So y greater than a number is still a horizontal line. There's no x, okay? So here, as long as y is by itself, you got to isolate that y or isolate the x. I'm going to go to -7 on the y-axis. -7 should be about right here. I am going to draw a dotted line. Do y'all agree with that? So a horizontal dotted line. And based on the inequality, do I shade above that line or below it? above. So as I start drawing my lines going above, I can start to kind of see where the shading overlaps. And it's this little corner over here. Do y'all agree? Okay. So I'm going to take out all these lines. So when it's all said and done, this was the area with the overlap. That was where we shaded below that line, but above this one. Any questions about that? All right. So I'm going to let y'all pick 3 or 4. Which one do you want to do? Number 3? All right. So inequality, first inequality, I have to rewrite. So x minus y greater than 1. Subtract your x. Divide by negative, which flips your symbol. So y less than positive x minus 1. Sometimes you do have to flip that symbol. We did divide by negative, so we switched our symbol. So our slope is 1, or you can write it as 1 over 1. Your b value is negative 1. That's going to be a dotted line, and we are going to shade below that dotted line. So start at negative 1, go up 1, to the right 1, and that's going to give us a line that goes like this. It is going to be a dotted line. And right now, according to the inequality symbol here, we are shading below that line. I need to do the same thing for inequality number 2. That would be x plus 4y greater than 20. That's 4y greater than negative x plus 20. I will not flip my symbol this time because I am dividing by a positive 4. So y is greater than negative 1 over 4x plus 5. So my slope, negative 1 over 4. My b value is 5. That will be a dotted line, and you will shade above. Everybody okay there? All right. So I'm going to start at 5. So go up 1, 2, 3, 4, positive 5. I have a negative slope, so I will go down 1, but I will go to the right 4. That is a dotted line. And we are going to shade above that line. So it's not until I get over here where the overlap starts. So all of this can go away, all of that can go away, and it's that one little corner up in the top. Any questions about that? All right. Now, you're probably not going to like me. That's okay. You are going to do 5 and 6 on a separate sheet of graph paper, which I am about to provide you. And you are going to turn those in. And once you turn those in as today's classwork, then you can grab a Chromebook and you can start working on your homework assignments. You will We should be done with this packet. Is that correct? The test for this packet is Sunday. It should be open today and it will close Sunday. Remember, you always have a 3-day grace period after Sunday. So if something happens and you don't get your test done on Sunday, try to get it done on Monday. Anything is better than a 0. But remember, after Sunday, you do get points deducted for that particular assignment. But like I said, anything is better than a 0. Okay? So you are to do 5 and 6. Let me get you some graph paper. You should not need more than one piece of graph paper. You can do all the work on that graph paper. If you don't, you can do your work on a separate sheet of paper. Put your graphs on the graph paper and staple those together. I believe y'all know the basket over there on the table where you are to put stuff. I'm going to leave the projector on because you have the weeks. Make sure you do put your name on it. And I know there are papers in the basket. I probably will not even get to those papers until this weekend, but they will get dealt with. If y'all have any questions as you're working through this, please make sure you're asking. That's what I'm here for.